We're now going to look at the various types of data that we have available to us in Java, or some of the simple types. So we've been using string so far to represent a string of characters. So we could say something like string name equals Andrew. But quite often we will want to work with other types of data. So for example, we might want to store values that represent true or false. Okay, so that's probably the most simple data type, and in Java it's called Boolean. Some languages shorten that to bool. So we might have Boolean, we might call it is hungry. Am I hungry? Not currently, I'm hungry a lot of the time, but I'm not hungry at the moment. So we can set that to either true or false. The only two values that a Boolean can be are true or false. We can't set it to anything else. Note there are no quotation marks around false because it's a reserved word, okay? So I can set it to false, I can set it to true, okay? It's case sensitive, so I can't set it to true in capitals, I can't capitalize the T. It has to be either true or false, okay? Some languages will let you do things like using 0 to represent false and 1 to represent true. That's not possible in Java. So the only things we can set a Boolean to are true or false. They're the only two possible values, okay? Another relatively simple data type is an integer, okay? And we can declare an integer. Maybe we'll do the year of founding of the university, which is 1839. And again, we don't need any quotation marks. So you might have realized that this is a string literal. Well, this is a Boolean literal, and this is an integer literal. Okay, again, we need the semicolon at the end. There are some constraints to the integer data type. So the integer data type uses 32 bits to store the int value, and the first of those bits is the sign. So integer value can be positive or negative. If we're only using 31 bits, there's obviously a minimum and a maximum value that we can store. So if we try and put something in around about the 3 billion mark, so that's with 9 zeros. So we're fine with 8 zeros. As soon as we go to 9 zeros, it's going to complain at us and say, well, integer number 2, and I think this is because I've got it in presentation mode, probably should say large. So we can't store that in there. So if we do something like 2 to the 31, 2 to the power 31 minus 1, that's going to be the largest positive number, and similarly I think it's 2 to the 31, or minus 2 to the 31 is the largest negative number that we can store. So we need to bear that in mind. If we need a larger number, we can use the data type, so let's put here up to about, it's about 2.1 billion. 2 to the 31 minus 1. I think it's the largest number. Up slash down. If we wanted a bigger number, we can use the long integer, and it's just called long, so it's a bit odd. So big number, and we've got 64 bits for that. So there is a capacity, there is a maximum size that we could go, which would be about 2 to the 63 minus 1. But we can store, so our value of 3 billion is perfectly fine. In fact, we'll go for 10 billion. So 10, 0, 0, 0, 0, 0, 0, 0, 0, 0, and we're still okay, except that this is an integer literal. If we want a long literal, and it's going to complain here, it's going to say this is an integer, it's too large. A long literal has the suffix L. So if we need to create a number that is larger than an integer, we can use the L suffix. The convention, although you can use a lowercase l, the convention is to use a large one. It might even be warning us. Yeah, it's suggesting that we should use an uppercase L. Okay, lowercase l can look a bit like a 1, and it tries to avoid that ambiguity. So for big numbers up to 2 to the 63 minus 1, up to so it's, or down to about, so it's minus 2 to the 63, but plus positive 2 to 63 minus 1, I think. You can certainly check that if you wish to. Now these are all good for storing whole numbers, but what if you want to store a number that ends with a number after the decimal point? So to do that, we've got two options. We've got float to represent floating point number, okay? Or we can use a more accurate version of that called a double, so a double precision floating point number, okay? It's generally minimally expensive, at least in Java and on most operating systems, to use a double. So generally it's sensible to use a double to get that extra precision. Although, for example, if you're working in games, you might find actually that saving of the number of bits. So double, I think, is 64 bits. Float only uses 32 bits to store the accuracy. So you get much more accuracy with a 64-bit. And we can store double values with a decimal point. Share of cake, for example, that might be 0. I don't know, let's say we've got, I don't know, a third of the cake. Okay, now for a double literal looks just like this with a semicolon at the end. A float, the lower precision, less accurate share of cake, that would have, oops, you can probably guess, but it has an F at the end, and again I'd suggest using a capital F. Now we do lose precision at some point, so let's have a quick look and just print out the share of the cake, less accurate share of the cake, and we'll just see if we've got this level of accuracy that we've given here. Yeah, so you can see that this has been rounded to 3/4, which is our second one, was our less accurate share of cake. So we need to bear that in mind, that we lose, I mean, it's not infinitely accurate anyway, and depending on the size of the number, the accuracy will change. Again, you know, if we get to numbers that are bigger than 2 to the 63, we're actually likely to use a double for that, and we'd start to lose precision at the sort of, you know, ones or tens or hundreds end of the number, depending on how large it is. But generally, if your number is that large, you're not so bothered about the individual digits, you know, if you're looking at very, very large numbers. Okay, so in general, the numbers you're more likely to use, at least on this course, are going to be double, int or long, and Boolean. Okay, and one other data type that I want to talk about, let's just label these up. So higher precision floating point numbers, less precise numbers, and the other thing, and you know, we've been using strings, but we can actually represent an individual character, and to do that we use the char or car data type. I never know what it is because character starts with ca, so I tend to say char, but I don't know if there's a correct way of doing it. First initial, so the first initial of my name is an A, and the literal for a char is the letter, one letter in single quotation marks. Okay, you can't put 2 in, so if I do that, it's going to complain. It's going to say something like not valid for a character literal. Okay, doesn't have to be a letter, obviously. We've got things like the ampersand, or potentially I don't know, a space, for example. If we try something clever like a quote, we're okay because we're inside an interliteral. What about if we want to have a single quotation mark? Then we can escape it like we would in a string. So we've got 2 digits in there, but that is still valid. This sort of approach where you've got a backslash can be used for things like Unicode characters where there isn't sort of a printable representation as well. But we'll put that back to, let's go for capital A. So they are some of the important data types available to us in Java.